Hi folks, and welcome back to Math with Captain Rod. I'm making this video here to talk about how to divide rational expressions and how to rationalize denominators if necessary. So let's see, as we look at these, I'll take a look at this first one. There's, again, different ways we can handle this. First, here's one method. We could write this as one radical, square root of 50 over 2, which is square root of 25, which is 2. I'm sorry, 2. 5. All right. Another way we can handle this is we could take this root 50 over root 2, and we could do what's called rationalization of the denominator. Right? So the idea behind rationalizing a denominator is get the radical out of the denominator. And one way to do that would be to multiply by square root of 2. But if I do the bottom, you have to do the top. So if we multiply the top and bottom by root 2 over root 2, look what happens in the bottom. You get square root of 2 squared, which is 2. There's no more radical in the bottom. That's what they mean by rationalizing. And then square root of 100 is 10. And this is equal to 5. So either way is perfectly acceptable. Again, I'm going to do most of the odds, but let me take a look at this one, this even one as well here. So we could multiply top and bottom by square root of 6xy. I think instead what I would do, let's write this as 1 under 1 radical. And then we can do this. 24 over 6 is 4. X over x, those go away. Y to the third over y is y squared. And then over 1, really. Square root of 4 is 2. Square root of y, y. Okay, this one, 3a here. So again, this one, what we'll do is we will rationalize the bottom by multiplying it by square root of 6. You have to do the top as well, though. Right? See, this is equal to 1. If you're going to multiply by something, it has to be equal to 1. All right? In the top, we have 1 times root 6. In the bottom, root 6 times root 6 is 6. This is done, right? And what we have done is we've gotten this radical out of the bottom here, and that's what the process of rationalization means. Over here, what you want to do is multiply this by root x over root x. All right, 3c here. Okay, rationalizing these. So what you multiply by, right, to get rid of this root 3, you have to multiply it by this quantity, and you'll see why when I do the multiplication. We're going to multiply it by root 3 plus 1, top and bottom. And the reason this works, it's because of the FOIL process. You'll see 1 times root 3 plus 1 is root 3 plus 1. Right? In the bottom, when we multiply this out, right, there's our first product. Root 3 times root 3 is 3. And here's the important part. The outer term is plus root 3. The inner term is minus root 3. So they add to 0. I'm not going to even bother writing. I'll just put plus 0 there. And again, that's coming from this plus square root of 3 minus square root of 3. And then the last term right here, right there, would be minus 1. So this is equal to root 3 plus 1 up top and 3 minus 1, which is 2 in the bottom. You'll notice there's no more radical there. For the reader here, the person watching the video, when you try this one, what you want to do is multiply this by square root of a plus square root of b, top and bottom. You got to do both. All right, moving on. Let's take a look at number 4. Oh, this one I think I would be tempted to write this all under 1 radical. And 32 over 2 is 16. X over x to the third. Let's see, that's going to leave us with x squared in the bottom. And then y to the 5th over y, that's going to be y to the 4th up top. Now we can just simplify these piece by piece. Square root of 16, 4. Square root of y squared, square root of y to the 4th is y squared. Square root of x squared is x. And now we can move on. Oh, they're getting progressively more fun. All right, let's take a look at this one. Let's see. One thing we could do is multiply it by square root 32 over square root 32. I think what we'll do instead here, let's talk about this. Let's see if we can break this up a little bit. All right, 128. Let's see. No, it's divisible by 2. Actually, 4. Let's see. 32, I believe. Yeah. And then 32, let's see, is 4 times 8. So 128, we should be able to write that 4 times 4 times 8. Let's see what we can do with that. So we got 8x root 2 minus 3 square root 4 times 4 times 8. And we'll clean that up here in a minute. All over root 32. Again, let's leave this alone for a moment. 8x root 2 minus, all right, square root of 4 is 2. Square root of 4 also 2. So we can bring out at least, we can bring a 4 squared. And in this 8, let me go back and write that 4 times 2. Okay. Sorry about this. So square root of 4 is 2, and then another 2, and then another 2. So that's 2 to the third, or 8, times 3 is 24. And then we're left with this square root of 2 inside the radical. All right, bottom, let's take a look at this now. That 32, let's see, we can write that about 16 times 2. All right, 8x root 2 minus 24 root 2 over square root of 4, 16 is 4, and then root 2. And the square root of 2 is common to both terms. I guess since I'm not going to bother with this one, I'll go ahead and write this all out. So like the square root of 2 can be factored out of the top. And then we're left with 8x minus 24. And then at the bottom, we've got 4 root 2. And these will now cancel. And I guess while I'm at it, we can divide a 4 out as well. Or we can factor a 4 out of this. Let's see, let me just rewrite the whole thing. All right, so we're left with 8x minus 24 over 4. You can factor a 4 out of the top as well. And then this would be a 2x minus 6. Let's just make sure 8x minus 24 over 4. These cancel. We are left with 2x minus 6. I'm sure there's a shorter way to get from here to here, but that's a valid approach here. Hopefully I haven't made any mistakes in that. I'm going to just move on. Solving equations containing radical expressions. All right, so what I'm going to do is just stop that video right there. Maybe chat a little bit about how to do a couple of these. So like this one, I think I would multiply top and bottom by square root of y over square root of y. In the bottom, you'll have the square root of y squared, which is y. This term, you'll have 2y times the square root of y to the 4th, and then this term you'll have minus square root of y to the 4th, and that can simplify pretty nicely. This one, I think I would just factor the square root of 3 out. In the top, you have square root of 3 times 3 minus 6 over in the bottom square root of 3, and these will just cancel. You could also just simplify the top. 3 root 3 minus 6 root 3 is minus 3 root 3. So that's enough to get you rolling on these. I hope that this video helps demonstrate how to divide and simplify these rational expressions. Have a great day.